Hello and welcome to yet another video of Cornerstones of Math. Today we have these three problems. The first problem is a simple factorization, and in second and third problems we have to solve some equations. So problem A is to factor the polynomial a to the fourth power minus 3a² b² plus b to the fourth power. Problem B is solving the biquadratic equation, that is, a quartic equation containing only even-numbered powers, x to the power 4 minus 12x² plus 16 equals 0. And problem C is solving another biquadratic equation, x to the power 4 minus 8x² plus 9 equals 0. And in case you're interested in this topic, I prepared bonus problem in the end. So let's get started. Problem A, factoring this polynomial. Here we can use the famous method called complete the square. Notice that if we split minus 3a² b² into minus 2a² b² and minus a² b², the first three terms form a perfect square, a² minus b² squared. And the last term is also a square, ab squared. So we can apply the square minus square formula to obtain a² plus ab minus b² times a² minus ab minus b². Next, problem B, solving this equation. Let me say this first. There are more than one way to solve the biquadratic equation. For example, one equally popular method is to use the substitution x² equals some other variable such as y. This will change the given quartic equation into a quadratic equation of y. This method is particularly useful when the resulting quadratic of y is easily factorable. If that's not the case, like this one for example, we can use the method that I'm about to explain. If you remember the previous result, you can easily realize that the left-hand side is the special case of problem A, with a equals x and b equals 2. You can use this to factor the left-hand side, or you can just use the same complete the square method to obtain the same result. Here, we split minus 12x² into minus 8x² and minus 4x². Then the first three terms equal x² minus 4², and the last term is 2x². So we obtain x² plus 2x minus 4 times x² minus 2x minus 4. So the equation becomes x² plus 2x minus 4 times x² minus 2x minus 4 equals 0. And with a quadratic formula, you can easily obtain the roots -1 plus minus square root of 5 and 1 plus minus square root of 5. Next, problem C. This one is a bit problematic because we cannot find the nice factorization for the left-hand side. That is, if we try to complete the square by splitting minus 8x² into minus 6x² and minus 2x², you'll notice that while the first three terms nicely form a perfect square x² minus 3², the last term 2x² is not a square. However, when it comes to solving equations, we can still factor the left-hand side by forcibly making this last term a square by introducing irrational coefficients. When it comes to factorization, the coefficients are conventionally limited to rational numbers, but we are trying to solve the equation here, hence the situation is a bit different. So in order to apply the square minus square formula, we write the last term as the square of square root of 2x. This gives x² plus square root of 2x minus 3 times x² minus square root of 2x minus 3. Therefore, we now have the equation this equals 0. And by applying the quadratic formula, we can obtain x equals negative square root of 2 plus minus square root of 14 over 2 and square root of 2 plus minus square root of 14 over 2. A quick side note here. When completing the square, instead of splitting this minus 8 into minus 6 and minus 2, you can also complete the square by splitting this into plus 6x², then minus 14x², which results in x² plus 3² minus 14x². This method also arrives at the same roots. You can check yourself if you want. Finally, as I said, I prepared this bonus problem in case you want to practice this method a little bit more. I will not provide the full solution, but I provide you the answer, which is the 4 roots of this equation, so you can check for yourself whether you can obtain this answer. And that's all for today's video. Thank you for watching. Please don't forget to hit that like button if you enjoyed this video, and I will see you in another video.